Okay, today what we want to do is we want to see if we can extrapolate what absolute zero is. Now, this particular app is already using Kelvin, so what should happen is as you decrease the temperature at a constant pressure, the volume should decrease, decrease, decrease until eventually you get down to zero. Now, what we're going to do is we're going to do it the way that it was done old school, okay? What scientists did is they actually took things and they measured the temperature and they checked the volume. They went down as low as they could, which was probably about maybe 100 degrees below Celsius, 0 degrees Celsius. So we're going to kind of mimic that. And then we're going to draw a graph to see if we can prove that if you go far enough, if you do keep good measurements, will you wind up with the projected volume actually reaching zero. All right, now that's a big mouthful. All right, so what we want to do is actually, I'm going to reset this. So if you click over here on the right-hand side, you'll notice at the bottom there's a little button that says reset. Click on that, and then we go down to 0. You notice it's 0 degrees Kelvin. I've actually shown right above the reset button, the ruler tube. You are actually, if it's not there, you want that ruler there. I'm going to click on it and drag it out of the site. You know, 0 degrees Kelvin, 0 atmosphere. We've got nothing in here. So I'm going to give each one of you a different number to use because absolute zero really works the same no matter how many particles you use. So in this case, we're going to use light particles, and I'm going to put in 300 of them. All right. Now, so I have 300 light particles, and I'm just going to hit enter. I want you to also, what I'm going to do is, you notice up at the parameters, the constant, I'm actually going to make all the parameters fluid. So I'm going to have 300 particles, and we're just going to let everything kind of adjust until it gets to like, until everything kind of readjusts. Now, one of the things you notice is it kind of put this in at the default temperature of 300 degrees Kelvin. As you guys know, 273 degrees is below zero, so that means 27 degrees above would be 300, and that's kind of close to room temperature. It's a little hot, but it's still it's around the temperature we live at. So now, what I would like to do is I'd like the pressure, everybody to try to work at the pressure of 1 atmosphere. Now, that's going to be a little tricky because we got 303. So the only way, if we can't change the temperature, the easiest way for us to get to 1 atmosphere would be to change the volume, and that's what I'm going to do. So on the left-hand side, you see the little man in the suit. I'm going to take it and I'm going to drag him out towards the left. Watch the pressure go down. Now, the reason the pressure is going down is because the bigger the box, the less frequently the particles will hit the walls, and that will make the pressure lower. So I'm just kind of eyeballing it. Right now it's 101, 102, 1.2, 1.1. There we go. That's right about 98, 97. That's about 9.8. Okay, 1 atmosphere. I'm just going to fix the pressure now. Go back to the right-hand side and click the pressure. And so now the pressure is constant at about 9.99 atmospheres. So it's around 1 atmosphere, which is what I was shooting for. You might also notice that when I messed around with that, the temperature also dropped because, of course, they have less energy. So the average kinetic energy is going to drop. So the temperature drops because they're in a bigger space. And so now I have just a regular thing. So what do I know? Well, I have 291 particles. I have a pressure of 1 atmosphere, temperature of 270. And the box, and again, I want you to notice how I'm lining this up. You notice the line above the 0 is on the inside of that wall there to the left-hand side. It's just there on the edge. So if I measure this all the way across, I've actually got 8 point and a little bit shy of 4. So I'm going to say it's 8.4. All right, so what am I going to do? Well, I'm going to go to my data sheet. I'm going to record my name. And I'm going to go with student 2. Number of heavy particles, and again, I have to go back and check this. I'm going to give you a worksheet so you can write all this down while you're doing it, and then you can put the data in later. I've got 286 particles, so 286 particles. Number of light particles is, actually, I think those were light particles. Yep, what do you know? So 0 heavy particles and 286 light particles. And then the length of the container in nanometers, I said was, well, I'm going to move it around a little bit, 8.6. So we're going to go with 8.6. 8.6 is the length of the 8.6. And the temperature in Kelvin, again, I'm going to look at that. And the temperature in Kelvin is 268 degrees. Cool. And then what's the pressure? The pressure is stuck at, whoops, I have to move this down. Perfect. Well, not quite perfect. 99.99 atmosphere. So 99% of the 0.99. Perfect. Submit. Okay, so now what am I going to do? I'm actually going to do about 5 of these. And what I'm going to go is, I'm going to try to go for a low temperature of no less than 100 degrees Kelvin, a high temperature of no more than 600 degrees Kelvin, and I want you guys to just pick a random number and just kind of go at random intervals, okay? So I'm going to actually now lower the temperature. The way I do this with the heat control, I'm going to take a little bit of the heat away, and I'm going to bring the temperature down to say, well, let's see, about 190 degrees Kelvin, and see what happens to the volume. Well, you notice the volume drops down to now 6, oops, it's still dropping, and it's almost exactly 6 nanometers, and it's 187 degrees Kelvin. So let's put that in. So go back. My name is still student 2. Okay, the number of heavy particles is 0. Number of light particles is 280. The length of the container was 6, I remember that. The temperature in Kelvin, let's take another look. Temperature in Kelvin is 186 degrees Kelvin. And the pressure should be held constant. And if everything worked right, it's a little bit, notice the pressure is dropping a little bit. Even our virtual box leaks a little bit. But it looks like it's about 197, 1.97, 1.98. So we're going to put that 1.98. Okay, so it's very close to 1 atmosphere. Okay, so I've got everything here. I'm going to hit submit. Boom. So there we go. So I'm going to keep on doing this. I'm going to add, and I want about 5 different temperatures, okay, that we're going to look at. All right, so that's what we're doing for now. And what I'm going to ask you guys to do is I want you to think about what's happening. The faster, the hotter it is, and the faster the molecules go, and the more they hit the sides, and that affects the pressure, but that also affects the volume. All right, and that's how they were able to calculate that if you go to this temperature that you can't really even attain on Earth, eventually you'd reach absolute 0.